be 100,000. 100,000 licenses. I want to have at least 50,000. 100,000, that should cover it. All I'd have to do is just have a 5-digit product key, and I would have at least 100,000, or I would have 100,000 different license keys for that. Yeah, you know, but that's okay, but maybe my product is really cool and it's going to sell to everybody, like a Cabbage Patch doll. Okay, again, that dates me. So I could put another number, or why don't I get adventurous and throw a letter in there somewhere? So let's put a 10, and so a number there, and then let's put a letter. 26 letters times maybe another number. Let's throw in another letter. And maybe for good measure, let's throw another letter at the end. Multiply those together. I don't have my calculator with me, but that would tell you how many different license keys there would be. And with that, there would be ample. Nowadays with Microsoft, boy, they've got a ton. Like to type in their product key when you buy something from them, you've got, I don't know, 20 digits long. Just think about how many distinct product keys there would be with 20 digits. Boy, that'd be a lot. All right. Now, with sometimes where, like that vice president thing, where you pick some and then you can't use one of those for the next pick, we can use something called a factorial notation. And we use that just as a simple way to indicate that there's so many different ways of doing something. So say, for example, if I have 10 people and I want to arrange them in a line. So how many different ways could I arrange them in a line? Well, the first person, there could be 10. The second person, since I've already used a person, I could have 9. And you can see how that's going to go down the road. Whoops, that would be a 7 times 6 times, etc. Well, rather than writing all of those out, what we do is we say, well, that's 10 factorial. And this symbol in math, exclamation mark in math, reads factorial. You can find it on your scientific calculator. If you have a graphing calculator, usually if you hit math, it'll be in one of those little menus down there, factorial button. Anyway, you just type 10, hit the factorial button, and it'll pop out the number of different arrangements that you could get. But factorial is used when you have that, you use one and you can't use it for the next one. Like you couldn't use this factorial for this one because I had 10 numbers that I could use here, but then I could reuse, and so I'd have another 10 here. I couldn't use factorial here because factorial says start with 10, once you've used one, then you've only got 9. Once you've used 2, then you've only got 8, etc. Here's something you can do on your calculator if you want. Figure out what 4 factorial it is. I could write it out. 4 times 3 times 2 times 1 be 24. Try it on your calculator. Here's an interesting one. You can do some games with factorial where you have 9 times 8 times 7 times 6 times 5 times 4. I need to keep going there. But on the bottom I have 3 factorial. Here I'm going to have times 3 and I have to keep going. But rather than keep going, I can just write 3 factorial. Then these two would cancel, and all I'd have to do is figure out what that is. It's probably easier just to do it on your calculator where you go 9 factorial, divide 3 factorial, bam, out pops your answer. Similar thing that you can do there. To determine factorial, you can also use or not to determine factorial, but to determine the number of permutations that you have for an event. You can also use a formula. There's a button on your calculator, but there's also a formula, this one right here, that you can use to determine the number of permutations you have for an event. So say I've got 10 people and I want to make a presidency of 3 people. So a president, a vice president, and we also always need a treasurer. So 3 people. So I have 10 people, and from those I want to know how many different arrangements I can get a president, vice president, and a treasurer out of that. So what I can do is I can use this permutation formula. And N stands for the total number of objects, in this case people. R stands for the total number of people or objects that you are drawing at a time. So in my example, if I have 10 people and I want to fill 3 slots, so I have 10 people and I want to find how many permutations I can get when I'm picking from 10 of 3 people at a time. So on my calculator, I can just go 10, pick 3. Or up here, I could use this formula here, which would say 10 factorial over 10 minus 3, or 7 factorial, and I could figure that out. I might as well just do it here. 10 times 9 times 8 times 7 factorial, 7 factorial on the bottom. So I just have to go 8 times 9 times 10, 720. So there would be, from 10 people, 720 ways I could choose, or not choose, I could pick 3 of them. Okay, so that's a permutation formula. Try these ones on your calculator, or try them using the formula. I won't write the numbers down here, but you can determine those. Okay, here's another example, and again, similar to one we've just done. How many 3-letter permutations can be made from the following word? So I have the word Hamilton. Notice that none of these repeat. If they repeat, special things I have to worry about. But here I've got, looks like I've got 8 letters altogether, and I want to know how many permutations I can make, and just using 3 letters. So I need to go 8, pick 3, and figure out what that would be. So 8 times 7, 56 times 6, I don't know what that is, 336 or something. I'll write it in there, but I'm not sure what it multiplies out to. But it's 8, pick 3. Here's another example. Hey, we did this one before. 5 people, from them I'm picking 2. And we did that before, but we used the fundamental counting principle. But here I can say, hey, I've got 5 people. Order's important, because one's a president, one's a vice, so I can pick 2 of them. So 5, pick 2. I think that, before I think that came out to 20. Now sometimes, if you have non-distinguishable objects, people, this won't work. I guess twins, you might call them non-distinguishable. I don't know. There's typically with twins a way that you can tell them apart. But if I have, say, balls, 5 red balls and 10 green balls, and the balls are indistinguishable, then that has a bearing on how many permutations I can get. Like, it lessens the number of permutations by quite a bit. But here's a formula I could use to determine that. And basically what they say is you take whatever n factorial is, and then you divide it by how many things are repeating. For example, how many 3-letter permutations are possible using the letters from the name Bob? Okay, so there's Bob. There's 3 letters altogether. So how many 3-letter permutations? I could write 3, pick 3 if I wanted to. But then I have to divide it by anything that's repeating. B is repeating twice, so since there's 2 of the same letters, I divide this by 2 factorial. Now, 3, pick 3, I guess I could have done it this way. I could have said 1 letter, 2 letters, 3 letters. And initially there's 3 to pick from, and then there'd only be 2, and then there'd be 1. So there'd be 6 ways that I could rearrange Bob. But because there's 2 B's that are the same, I have to divide that by 2 factorial, which is 2 times 1, or just 2. So there'd be 3 total permutations of 3-letter orders using Bob. Okay, you're probably dying to get to Mississippi. Pause and see if you can figure out how many arrangements of the word Mississippi there'd be. Okay, hopefully you pause there. Here'd be the answer. Count up how many letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there'd be 11 factorial ways of rearranging those letters. Notice I'm not picking some from there. I'm just rearranging all of them, like I did with Bob. 11 factorial. Now I have to divide that by the repeaters. M, there's only 1. Okay, now I's. 1, 2, 3. There's 4 I's. So I'd have to divide this by 4 factorial. Oh, and there's 4 S's. So I have to divide it by another 4 factorial for the s's. Is that it? Oh no, there's 2 p's. So divide it by another 2 factorial for the p's. So that would give me the total number of arrangements using all of those letters of the word Mississippi. Okay, so today we have looked at permutations, found that they are orders of or arrangements of letters or numbers or whatever we have. The key thing was that order was important. Try some questions in your text and on the quizzes. See if you can use those formulas, the formulas and the concepts we talked about in this section. Thanks. We'll see you later.